Okay. Alright, so we'll get what's left of this thing with a pair of dikes and hopefully unscrew it and save our piece. Looks like we're going to be okay. Okay, get our piece of tap out. We'll get a new tap. We saved our piece. We'll continue on with it. Okay, so that was most unfortunate. We're back to hand tapping now. So we'll move out an appropriate distance to get the next hole. Okay, so no power tapping this time. We're just going to use our quill to start the thing straight, and then we'll finish it by hand. Okay, so we finished running those threads through by hand and see how it all fits up. Okay, so that worked out well. We got our valve body bolted on. Next step, I guess, is to drill and tap our 1/8 pipe into here to install the fittings Stan sent us to hook this thing up. So if we did our homework right and we got all this laid out properly, we should be able to flip this over, align it to our jaw again, and dial in our 2 holes to drill and tap for our pipe fittings. So it's flipped over, we dial in the same numbers as we used for the first hole and just use our drill bit. You know, it's close enough for the girls I'm seeing. So let's get the right size tap drill for our pipe and a tap and run those in there. So this is tap drill size for our 1/8 pipe, and I was going to drill it all the way through, but I don't think I'm going to leave myself enough sealing area between the motor here and the gasket if I do that. So I'm going to try to run this thing through the bare minimum I need to get a pipe thread tap in there. Let's check it out and see how it goes. So this is 1/2 inch material. I think what I'm going to do is bring my drill bit down till it touches here, and then set my quill stop down as close as I can get it to probably 7/16, I guess. And if we need to, we'll increment it down a little bit until we get just the tip of the drill bit showing through the top side, so we leave enough material for our gasket. I'll let you know how it turns out. I guess if I'm right, I'll feel the tip of the drill bit touch my finger right near the end of it. If a finger comes up through the hole, you know I went too far. Okay, we can stand to go down just a hair more, so let's run one more thread on our depth stop until we find the right depth. No drill bit yet. One more thread. And of course we'll get the phone. So I think we can stand to go down one more thread. So let's try that. now, I can just feel the tip of the drill bit pretty much flush with the bottom side. So we'll try tapping there and see how it goes. Not quite enough, I don't think. Let's try that, a little better view. Yeah, we may not get a full thread there, but I think for our intents and purposes, I mean, let's face it, this is not propane gas we're doing here. I think we might be okay, because I'd rather not drill all the way through and then risk leaking on the gasket. Okay, so let's remove our dollar store die cam. So I think this is going to function pretty good. By rights, our pipe thread should have been tapped a little deeper, but we will get more than half of the thread in there. So I don't think it's going to be a problem. So we'll assemble this front, and the way I've got it planned to go, of course, is this will be the front. We'll have our hoses connected all at the rear, and we'll have a little handle on top. Should work out okay. Okay, so this Stan graciously provided 8 miles of hose. I had a somewhat ambitious plan to mount this control down on the knee and run it up top. I'm not sure if I have enough to make up for all axes of travel of the machine, but there's more than enough there to mount it in a standard location, I guess, but I'm not all that standard, so. And I'm a lefty, so I like to have control on my right and grab cutters with my left, so we'll see how it goes. We may have to revert back to the standard left-hand mounting position. We'll see. Okay, so it's Friday. Everybody's gone home, and I need a piece of plate to finish my power drawbar. So I have a piece of 3/4 inch aluminum plate, and we need to hack the piece out the end of this. So I've cut aluminum on the table saw before, but never 3/4 thick. So we're going to give it a go, see how it works out. Don't try this at home. Who says cheap ass table saws are no good? Let's get some dimensions on that. We'll square it up and do some layout on it, and we'll make a crack for a drawbar out of it. That's a roughly squared up piece for the top plate on our power drawbar. How exactly we're going to use this is still a mystery to me yet too, so hang tight. So I've got an idea in mind what I want to do for the upper plate on this power drawbar. Sketched up a bit of a diagram. I'm not sure if I'm ready to tackle it or not. It scares me, and I drew it up way too many numbers in a small area. So we're lined up 0, 0 on our back corner to give us a reference point in case we have to take this out and put it back in, lined up with the edge of the jaw. I think I'm going to do an idiot mark on this corner so I know what's what. I'm going to paint pen. And we'll get to cutting, I guess. I think what I'm going to do is center drill all these holes. We have 6, 8, 9 holes to do. I think I'm going to go through the pattern, center drill them all, make sure everything works out right before I go in and ruin the piece, because I may stand a chance to save it if it's not right. Do I drill the holes? Big decision. Yeah, the diagram's got to be right there. So this measurement is done. This hole is done. So we'll scooch on over to this one. This one is done, so that's those 2 holes. Now we're in the process of this one. So we have our 2 191, cross that one off, and now we need to be at 2 5 5 7. So that would be this one. Done. Next one will be at 3 6 1 7. So I think to check this hole pattern, I'm going to grab the bolts from our air motor and our gasket. Looks good. I think we're going to be okay. So this is going to be the top of the unit, and these 2 air holes need to be drilled out and tapped to our 1/8 pipe. So we'll probably do that now before we go into our 3/4 inch holes, or our 1 inch holes rather. So in drilling our tap drill size, I don't want to go all the way through the plate and leave too big of a hole so that it doesn't seal around the motor. So I'm going to zero my drill at the existing hole and use my quill stop with a parallel to set my 5/8 inch I want to come down. And they're both the same. Goes tight, it goes tight. Okay, tap handle. So we're tapped for 2 of our fittings, bolt holes line up. What's left? Counterbore our cap screw holes, and we need couple of 1-inch holes here for our brass bushings. Okay, so while you guys were gone, I got a little more work done. I countersunk our bolts and roughed out a couple of 3/4 inch holes that we're going to enlarge up to about 9/98 now. Set up our power feed. We've got our depth already set. Grab a snap gauge. Maybe the cheap calipers aren't that bad after all. Probably that good. So here's a quickie overview of tonight's progress on the upper plate. We got our motor is mounted to it, the holes countersunk, air lines are threaded in place. Turn this around a bit. Our air cylinder hole is not done yet, but we will get to that one eventually. We need brass bushings for up here, and we need to pretty this chunk of steel plate. We need to pretty this chunk of aluminum plate a bit. It doesn't fit with the rest of the design here, so we'll have to do something a little special with that, I guess. Stay tuned, don't change your channel. Okay, so Saturday morning I get to play a little more with this. What I have in mind now is to make 2 bronze bushings to go in here to slide up and down on the rods. Our springs are going to fit underneath these things, so we're going to do a little shoulder here to keep them from pushing up through. They're not going to be a heavy press fit anyway. They're only going to be just very light, and and they'll have a shoulder for our spring to touch on. Already got our piece of brass faced. We're going to center drill and do a rough hole, probably 5/8 or so, in the couple of inches that we need. Then we'll turn our OD and we'll do the finished bore back with a boring head in the mill to make sure both bushings are perfectly parallel and to size. Nothing overly critical. We're going to scale off our 2-inch dimension and get it to size, part it off, and we'll do a face on the other end. Okay, we'll finish our shoulder, do some beveling, and we'll part the thing off. So I'm going to give myself a bit of 100 on the shoulder. We'll face the guys off after, and another culprit just like this one, and so we're both cut. We'll flip them around in the chuck and face the end that's going to seat against the spring, and get them to an equivalent thickness, and we'll go on to the mill, I guess, to finish the ID. Yeah, that's probably good enough. Like all my stuff, specs are subject to change without notice. Okay, so like always, I thought it over and changed my mind. I didn't make these into a press fit, actually. I took some paper and polished them down until they were pretty good. I'm going to call it a Loctite fit, because that's how they're going in there. And that way they can be removable later easy enough if they should happen to wear. I also have to do some finishing on this piece, so I don't want to press these bushings in place yet. So that much is made up for now, and we'll work on doing some shaping on this guy. So to give this upper plate a bit of curvature, I've went back to the CAD again and draw out how we can hack some metal off this upper plate and give it a rounded appearance and make it a little smaller and more streamlined. So I drew out a 5-inch circle, centered it up so I have a decent amount of overhang on all parts of this, and just get some center measurements from our origin corner there, and go to the mill and lay out a center hole there. So I got a few of these Lipton layout lines on there with our dollar store die chem and a pair of dividers. It'll mark out the rough circle that I'm going to take off of here, and I'll take out a bunch of this with a bandsaw, and we'll finish the rest in the machine. So let's get to our coordinates that we got laid out for our center hole. 93. Over this side, 3087. Let's move our cord. Get up to an 87 here. So that'll be our center mark for this 5-inch arc. Do it. So that'll be the centering mark for our next operation. So do you ever have one of those days when the small bandsaw is just not fast enough and you're running out of patience, and you know, so you look over it in and say, gee, that plasma cutter should make quick work of this, eh? So I did. And I cut the corner off, so we had to break out the TIG and do a little build up here before we go on to our next step. Oh well. So this is my plan to cut this outside curve on this upper support plate, and I think Mr. Lipton is doing something very similar in his video today as well. He's always copying me, see why? Now, so when we get those adhered, we don't have our piece clean yet, but what I drilled this center locating hole for was to use our tailstock and align our piece centered on our 2A tape. So then we'll press it in place and use the jaws of our forejaw to drive our piece and do the outside curve on the thing. We'll see how it goes. If I had a thumbnail, I might be able to get this off. So we've got our part degreased. We use our tailstock to hold it. And bring our apron up far enough so we can actually do the thing. So we'll hold it as square as we can and then push it in until it makes contact. A little bit of pressure on it, not a bad idea either. Okay, so now that that's in place, I'm going to swap out the dead center for a log as our security so the thing doesn't come off. I think Tom calls his a chicken bolt. So I guess I'll call mine a chicken center. And hopefully we have enough room to run across the face. What do you think? Doable? So I just did a little skim cut to find the highs, which are no doubt where we did the weld over here. So let's try to take off a few passes and see what happens here. touching in about 5 or 6 spots there now. So we have our scribe line to go by, so we'll face down pretty close to that. So I can see at this slow speed it's going to be hard to get the surface finish I want to get on this. Maybe I'll switch to a high-speed tool near the end and see how much better it does. So if I can't get the surface finish I want with speed, I'm going to try a piece of high-speed steel. So we just ground basically standard right-hand tool. Holding our edge good and sharp. So we'll get our center height set and see what kind of a finish we get with this one. It is better. The welded area is a little more, a little duller looking. Let's work our way into our line, see what happens. Okay, so I think this will be the last cut of about 15 thousandths. Well, I did clean up the whole diameter, so I think I'm going to have to be okay with that. We'll run a bevel on each corner and get back to repairing the bushing hole. So after our little plasma cutter faux pas, we did manage to save the piece. A little weld build-up on the corner here, and surface finish, while not what I wanted, is not terrible, so we're going to leave it. And we did manage to meet our spec on our overhang in the corner. So all we have left to do now is rebore this hole for the bushing, and then bore the bushings themselves to fit our 3/4 inch posts. So I've set it up on our first bushing here. So we'll go ahead and we'll bore this one to our 750 to fit our rods, and we'll move over 375 and get that one done as well. Okay, through careful analytics and judicious use of our scale, we've determined that we need a 1.5 inch spacer here to control the height of our impact unit when it's not in use. I'm just going to make these up really quick on the lathe, throw them in there and give you a look at it. So in setting this thing up here, I'll turn it so you can actually see the clearance. We need to know our distance fully compressed. And on our cylinder here now we have about 3/4 inch. So if we release this thing and let it come up to where we get an adequate clearance in under here and bring it up, we're down to about 3/8. So our spacer we're going to put in this air cylinder is going to be somewhere between 3/4 and 3/8. I think I may just split the difference and leave it at about 5/8. Which will still give us a full inch of travel down onto the drawbar and won't allow the cylinder to bottom out. Okay, so here's the first test operation of this whole shebang. Should work, can't see why not. Got a few more pieces to make now, and we have to finish our handle, put a gasket in here because it's leaking like a bugger, and get her mounted up on top of the mill and try it out. So I think I've got this power drawbar wrapped up. I'll show you what I did for my control mechanism. I put it on a magnet so I can move it around. It's pretty much a copy of Ray's handle and control, and but I put it on a magnet system so I can move it around, stick it on a knee if need be, or move it somewhere more convenient depending on what kind of a job you're doing, or just get it out of the way altogether. It works pretty good. I like that. So this is the completed unit, mounted in place and functions well. I'm quite happy with this one, and makes tool changing a whole lot easier. Thanks a whole bunch to the boys that helped make this project possible. Mr. Herb Blair, Stan Zinkoski, and Ray Caniglia. Thanks, guys.